Computers build logical gates using these switches, okay? Electrically activated switches. But what are those switches? Well, the technology has evolved a lot in just maybe 100 years. The first switches were made of vacuum tubes. I'm sure you have seen this before. They are still used in some circuits because they have very special characteristics. They are like the old bulbs. They are big. They the old ones failed easily, and the problem is that they are very, very big. So, for example, if you need a computer with to add 8 bits, you need, remember, 80 switches. So you will need a place to put on 80 of these kind of devices. So it's going to be big. So the first computer used that, and they were very, very, very big. So after that, the transistor was developed, and it's much smaller than the vacuum tube. So, for example, this is a battery, a bottom battery, and this will be a, a transistor. This will be the smallest one in this image. Is much, much smaller than the vacuum tube, and this will be another model, another model. You can still build that because they are used in some circuits. You can go to an electronic store and build a single transistor. If you take a look at it, it have three three connectors, because remember, this is how I draw it. This will be one of the connectors, the second of the connectors, and the third one. They are not just switches. They are very complex. You can use transistors for amplifying signals and a lot more. But in computers, we are using that as switches. Okay, and after that, the chip was developed. So this is a chip. You have seen lots of chips before. Remember, with a lot of connections here, and the transistor are drawn into the chip in a very, very small scale. So, for example, this is a chip into a microscope, and those are the switches. Okay, those are the transistor built using some advanced technology like quantum effects and something like that. And the size of a switch of a transistor inside a chip is around 10 nanometers today. 10 nanometers, maybe 14 nanometers, 10 nanometers, and that is something very, very small. So, for example, here we have a picture with some human viruses. I'm sure you know this one. This is the coronavirus. This is 80 nanometers length. So, if we have gates of 10 nanometers, it will be something like this. So this will be the size of a logical gate of a transistor inside a chip compared to a coronavirus. So we can put 8 transistor in the same size of a coronavirus. So you can see they are very, very small, and we can put millions and millions of them inside a small chip, and that is what gives the chips the power that we have today.